Okay, continuing with rational expressions. Okay, we have complex fractions, and there will be varieties of these. And let's say if we have an expression such as a all over b over c, and as a division statement, so you have a divided by b over c, and you can write this as a over 1 divided by b over c, and we have in the crossover, if I write this statement in terms of multiplication, so I have a over 1 times c over b, and for the final result, okay, so this will be ac over b. And let me give you an example. Say if I have 10 over 3/7. Okay, so I have 10 divided by 3/7. So I have 10 over 1 divided by 3/7. Yes, by then you could have gone ahead and rewritten in terms of multiplication. So we have 10 over 1 times 7/3. And we have for the end result, we have 70/3. So in this one, we already have the ratio in simplest form. Now, and let's say that if I have a over b all over c, in this context, so I have a over b divided by c. You can also write this as a over b divided by c over 1. And then writing in terms of multiplication. So I have a over b times 1 over c. And this will end up as a over b times c. And just a quick case here. Let's say if I had 10/3 divided by 7. So just in line with what I have in this formula. So I have 10/3 divided by 7. Or 10/3 divided by 7 over 1. And dividing by 7 over 1, same as multiplying by 1/7. And so we have for the end result here, okay, so you have 10 times 1 is 10, 3 times 7 is 21, so we have 10 over 21. Okay. Now let's say that if we have a complex fraction, say we have a over b, and we have divided by c over d, so in direct terms, you have a over b divided by c over d. Rewriting in terms of multiplication, so you have a over b, and I have times the reciprocal where we have d over c. So it will come out to a times d over b times c. And let's say that, as an example, if I have 2/7 divided by 3/4. So 2/7 divided by 3/4. And rewriting what we have here in terms of multiplication. So you have 2/7 times 4/3. 2 times 4 is 8. And 7 times 3 is going to be at 21. Now, and let's say that if we have regarding complex fractions, and let's say if I were to simplify this particular complex ratio where we're going to have a mix of addition and subtraction. Now, let's say that if we have ratios here, and we'll say that we have 3 over 4 a squared b to the third. And say if I have plus 7 over 2, a to the 5th, b. And let's say that if I have this ratio, the sum of ratios all over, and we'll say we have 5 over 6, a to the 4th, b to the 7th, and I'll say that I have minus 1 over, and we'll say that we have 10, a to the 3rd, b squared. Okay. Now, again, just taking what we have, if we look for the least common denominator, now we got 4a squared b cubed. Now the prime factorization for 4, we have 2 times 2, and we have a squared b to the 3rd, and we got 2 a to the 5th b. 2 is already a prime number. We have a to the 5th b. Now for 6, a to the 4th, b to the 7th. So we have 2 times 3 times a to the 4th times b to the 7th. Then we have a 10a to the 3rd, b to the 2nd. Prime factorization, so we have 2 times 5 times a to the 3rd, b to the 2nd. And for what we have, okay, for the least common denominator, okay, so we had prime factors with 2, greatest number of appearances of 2, we have 2 times 2, and we have the appearance of 3, and also we have the appearance of 5, and for a and b, we're going to go with the highest degree appearances, so we have a to the 5th, and for b, we have to the 7th. And so just tying in what we have here, so you got 2 times 2 times 3 times 5, and you have a to the 5th, b to the 7th, and we have in this case, right, so we have 4 times 3 is 12 times 5 is 60. So you have a to the 5th, b to the 7th. So in taking what we have for the ratios, okay, and so just lining up what we have all together. So if I raise the fractions, now there are various ways that you can simplify, but I just want to kind of keep this in line with what we have done earlier. So you got 3 over 4, a squared, b to the 3rd. And again, I'm going to put this in terms of the least common denominator. And so we have 4 into 60 is going to be 15. And for a squared b cubed, a squared into a to the 5th. Okay, so we have a to the 3rd, a to the 3rd, b cubed and b to the 7th, so that's going to be b to the 4th. And we have plus 7 over 2, a to the 5th, b. And taking what we have now, so we got 2 into 60 is going to be 30. And we got a to the 5th already, b into b to the 7th, so that's going to be b to the 6th. Okay. Now for what we have in the denominator, okay, so you have 5 over 6, a to the 4th, b to the 7th. Six into 60 is going to be 10. A to the 4th into a to the 5th is going to leave us with a. And we already have b to the 7th. And as for what we have with minus 1 over 10a cubed, b squared, and here, okay, 10 into 60 is 6, a cubed and a to the fifth, that's going to be a squared. And b squared into b to the seventh, okay, so that's going to be b to the fifth. All right, so for what we have out of these ratios, we already have in terms of the least common denominator. And so taking what we have now, okay, so we're going to have everything, okay, of the least common denominator for both sets of ratios. And for what we have for the numerator terms, we got 3 times 5 is 3 times 15 is going to be 45. A to the third, b to the fourth. Seven times 30 is going to be 210. B to the sixth. And for what we have in the denominator part, and we have here, okay, so we have 50a minus 6a squared b to the fifth. We have all over 60a to the fifth, b to the seventh. And you can see sort of implicitly that the least common denominator is going to cancel out. Again, this is not the only way to work out this problem. But for what we have in this case, all right, so we have in the reduction, so you have 45a cubed b to the fourth plus 210b to the sixth over 60a to the fifth, b to the seventh, and dividing by the bottom fraction be the same as multiplying by the reciprocal. So we have cancellations here, and so with what we have left over, okay, this is going to come down to what we have left. So we have 45a cubed b to the fourth plus 210 b to the sixth, and we have all over 50a minus 6a squared b to the fifth. Again, this is sort of long and drawn out. Again, this is not the only way. There is a bit of a shortcut route, but for what we have at this stage, I decide to sort of lay out the approach, and this is your result.